In this video, I'm going to perform a hands-on demonstration of what happens when you override a method and then invoke super to get behavior from the superclass method. I have an existing project that already has a vehicle class, a Sonic, a Mustang class, and we're going to make a Prius class here that represents the hybrid behavior that a Prius has, where sometimes it can run on gasoline and sometimes it can run on electricity. So that's a bit of a modification to what we would call a normal vehicle. We have a requirements document that we use to create our first test, and we're going to implement test-driven design for this because we already have the test. So let's note that a Prius is a vehicle, a Prius is hybrid. Moving a Prius can impact gallons of gas and or milliamp hours, or in other words, the charge. We'll just call it the charge. Prius gets 50 miles per gallon when using gasoline. When using gas, the milliamp hours increases by 1 for every 20 miles driven. And now we have our given when then test. So given gallons of gas is 10, odometer is 0, charge is 4 milliamp hours. When the vehicle runs 100 miles, then the gallons of gas decreases to 8. So 100 miles divided by 50 miles per gallon is 8. The odometer is 100, and the milliamp hour charge is 9. Now, we also know that when we're using electricity, the milliamp hours decrease by 1 for every 25 miles driven. If the charge is less than 5, then the vehicle should use gasoline. If the charge is greater than 5, the vehicle should use electricity. So that's essentially where we're going to make a decision of, should we call the superclass functionality that uses gasoline, or should we implement our own functionality where we're using the battery's charge? So we have a test here. Given gallons of gas is 10, odometer is 100, and charge is 9 milliamp hours, so greater than 5. When the vehicle runs 100 miles, then the gallons of gas remains constant at 10, the odometer increases 200, and the milliamp hours decreases by 100 divided by 25, or 4, and that takes us down to 5. So let's implement this. We'll start by using our test-driven design. So if you see the requirements document we worked on over here, you see that we've already written a test that mirrors that requirements document very closely. Even the words we use in the methods are very close. So with test-driven design, we write the test first, and then we write the code that makes the test pass. Well, order of business number 1 is the test has to compile, and right now it doesn't compile. So if we take a look, we need to take care of the red lines. First one is Prius. So I choose Alt-Enter and create class Prius, and we'll put it in source main Java, not source test Java. Now back to Prius test, and we'll see that now it recognizes the Prius, but it doesn't recognize the set gallons of gas, set odometer, set miles per gallon method. Well, that's because we need to inherit those from the superclass vehicle, and we can do that very easily with the extends keyword. So back to our Prius, and I simply say extends vehicle. And take a look at our Prius test, and we see that now we have fewer red lines, but we still have the set charge get charge. Looks like we have a couple items going on there, but once again the IDE can help me out. I hold Alt and press Enter on a Windows keyboard, and I'm going to say create property charge. And I say let's do it in the subclass Prius because while all cars have a battery, not all cars can run off electricity, where a hybrid car like a Prius can. So I choose Prius, int is fine, and it creates the getter and setter methods for me, and creates the attribute for me. And now I go back to Prius test, and what do we have redline-wise? In this case, it looks like one little mistake I made in the test. I should have used new before invoking a constructor. So I fixed that, and now our test at least compiles, and we can run it and see where we need to focus on fixing. Run with electricity. It looks like we have an assertion failed error or maybe some kind of warning here, and then run with gas. We have a null pointer exception. The null pointer looks to be a small mistake in my test. On my first test, I'm not creating a Prius object in the given, which I should. So yeah, okay. Test-driven design, we found a mistake in the test. No problem. Let's go ahead and fix this, and then run the test one more time and see what we get. Now, it looks like we have a couple of failures here. So one of them is expected 9, actual 4. Nice thing is, with the stack trace here, we can see exactly where the failure is. So, okay, then gallons of gas, 8, odometer 100, milliamp hours 9, and this one is invoked on running with gas. So you see what happens here is we're inheriting the go method from our superclass, but we're not taking care of that case with the Prius where running with gasoline charges the battery. So the odometer's fine, the gallons of gas are fine, but we're not accounting for that battery charge. So let's take care of that. I'm going to go into my Prius class, which right now just has this charge attribute, and I'm going to override the go method from the superclass vehicle. So if we take a look at vehicle, we need to make sure that we mimic exactly the same method signature. I take that down to Prius and I paste it. And for the moment, let's just assume we want to use that same behavior from our superclass. So I'm going to say super.go, and then we'll pass that miles driven directly up, because remember the signature has to be identical. And both go methods accept an int, which indicates miles driven. Now for the moment, let's just take care of the miles per milliamp hour charge. And if we remember from our requirements document that the milliamp hours increases by 1 for every 20 miles driven. So that's a very simple equation. Charge equals charge plus miles driven divided by 20. So driving 100 miles would increase the charge by 5. Best practice is we should make a constant out of this to make it a bit more descriptive. Right-click, refactor, extract constant. Charge denominator is a bit more descriptive than just the number 20. We could also say it miles required for 1 unit of charge or something like that. But we get the idea. We use a constant. All right, let's run our test again. Remember, right now we have 2 tests that are failing. We've just focused on 1. Let's see if we're able to get at least 1 to pass now. And sure enough, we now see go running with gas does indeed pass. So we have inherited the behavior that we need to inherit from the superclass, as well as adding additional behavior that's specific to the subclass of Prius. Now, we still need to handle the electric type, but at least we got 1 test to pass. And that's the idea with test-driven design, is we're getting 1 test to pass at a time until we get them all to pass. So running with electricity, expected 10, actual 0, and that's looking at our gallons of gas. So you see that when we're running with electricity, we should be using electricity and not gasoline, but we're currently not set up to do that. If we remember the rule, if the charge is less than 5, the vehicle should use gasoline. If the charge is greater than 5, then the vehicle should use electricity. So let's go back to our overridden go method and add an if test. So you see if the charge is less than 5, we want to go ahead and do the behavior we would normally do. And if I control click, we can see that takes us right up to our superclass called vehicle, and there's the behavior from the go method. And then we want to add that ability to increase our charge as we're driving. On the other hand, if the charge is greater than 5, then we want to use our battery charge, and we want to increase the odometer, but we don't want to decrease the gallons of gas. We remember that the consumption of milliamp hours is 1 for every 25 miles driven. So we see miles driven divided by 25. We're going to subtract that from charge. Notice I used a little different syntax than I used on line 17. These, except for being plus and minus, are both the same. So charge equals charge plus formula is similar to charge minus equals miles driven. That simply means it's a shortcut for charge equals charge minus miles driven. So miles driven divided by 25, of course, once again, we will extract a constant. We'll simply call it miles per milliamp hour. Once again, by using a constant instead of a magic number, we have more readable code. So we decrease the charge, and now we need to increase the odometer. Now you notice in this case, I'm using set odometer and get odometer instead of a mathematical equation. So get odometer, add the miles driven, take that quantity, and set that to the new odometer. So why that? Well, some people prefer to do it that way instead of talking to the variable directly, although we do have another option we could do. If we look at the superclass vehicle, we'll see that odometer, being an encapsulated field, is private. That means that a subclass cannot read that encapsulated field, to that field directly, can't read or write to that field directly. However, it is exposed through getter and setter methods that are public. So our subclass can access those getters and setters. If we were to change this to protected, then we would be allowed to have direct access in our Prius. And I'll just put it here so we'll have it for reference. You see with direct access that becomes a little bit of a simpler equation. Either one's going to have the same result. We just don't want to do both because then we'll have a bit of double counting. Let's go back to our Prius test now and see what the results are. And both tests pass. One thing to consider is that JUnit tests are debuggable, so we can walk through at our own pace to watch how it's working. And also, if the test breaks, that gives us an opportunity to see why it's breaking. So I'm going to set a breakpoint on each of my test methods, and then we're going to go in and see how the go method is impacted in Prius. As a matter of fact, I will snap a breakpoint on the go method just in case I go too fast on the Prius test, and then I right-click and say debug. Okay, first test is started. We remember that we have our keys down here at the bottom. Step over, execute this line, go to the next is F8. Step into is F7. That means walk into this method call. So I'll go ahead and choose F7, F8, F8, F8 as we set up our Prius. And then we're going to drive 100 miles. Press F7 for this. Now, watch up at the top where I have the tabs so you can keep track of where we're going here. I'm currently on Prius test. I choose F7 to step in. Now we're in this go method. Look at the top. You see that I'm in Prius Java. Now, we choose F8 is charge less than 5. No charge is not less than 5. So we are going to use the battery. And notice we never have to invoke super in this case. We're simply saying, okay, all of the logic is here because that hybrid concept is unique to the Prius over the more general vehicle. Now I tell the debugger to keep going. And once again, we are in a test. I'm going to choose F7, which is going to step me into this given, very similar to the one that we saw before. Now F7 is going to step me into the when. We're still in Prius test. Watch what happens when I press F7 now. It goes to Prius. Now, what is our charge? Well, our charge is 4, which is less than 5. So we need to go into this part of the if test. Once again, watch the tabs very closely as I press F7. Because I'm stepping into this go method now. Where's the go method? Oh, the go method's on vehicle. Because remember, we use that super call to step up into the vehicle and use logic from the method that we're overriding when convenient. And then when that wraps up, because we are in a hybrid vehicle, we're back to our Prius again. And within that Prius class, we know that we need to increase the battery charge when we're running with gas. And with that, we're all set. That's what I think is a really easy way to learn code, is snap a breakpoint on the tests, and then just walk through it in the debugger, and you can visualize exactly how things are working. So let's connect the dots here. Go running with gas, given gallons of gas 10, odometer 0, miles per gallon 50, charge 4, and then we have given when then there, and then we have another given when then down below. We know that those given when thens match exactly, or nearly exactly, to the examples that we elaborated here in our requirements document, and those examples tie us directly up to the requirements. So the question now is, have we met the requirements? Well, yes, we have, because the code that we wrote made the test pass. The test is a near exact duplication of the example. The example is an example of a requirement. So at this point, we can say our test had passed. Even better, when I commit and push this, and I remove our previous exclusion of these test-driven design tests, and make sure, of course, that gets committed and pushed as well, we can see that our CI/CD pipeline runs and GitHub Actions, it's actually merged this into master. But we can see, sure enough, there it changed to a green check that indicates all tests have passed. So not only do we have our code complete in the test passing, but we can also see that feedback immediately in GitHub with GitHub Actions. So this has been a look at how to override a method and call super, and then also add some behavior that's specific to a subclass. As always, I hope this video was helpful, and I look forward to reading your comments. Thank you.